Hello students. So today we'll be seeing about the last part of unit 4. So today's agenda is you will be learning about connecting an Arduino and Raspberry Pi to the web. Next you will be learning about setting up the Arduino or Raspberry Pi development environment, and you will be seeing about options for internet connectivity with Arduino, configuring your Arduino Raspberry Pi board for the IoT. So here you will be learning about the basics of Arduino. So Arduino is an open source electronic platform which is designed to simplify the process of building digital devices and interactive projects. So Arduino was initially developed at Ivera Interaction Design Institute in Italy to help students and research scholars without the background in electronics or programming in their ideas. So over time it has evolved to support a wide range of applications from IoT where devices and wearables of 3D printing and embedded systems can also be used. So you have to know what is the use of Arduino. So Arduino is widely popular due to its simplicity and versatility. So it is used by students, artists, and other professionals for various purposes, including robotics, scientific instruments, and interactive installations, and so on. So we have so many advantages of using this Arduino boards, which are very affordable, with some model costing less than $50. So it is very easy to use the hardware and the software to enable users to create systems that can read inputs. So we have some examples like light on a sensor, a button press system, or a message, and it produces output activating a motor, turning on to an LED, or publishing data online. So when you consider the Arduino, it is considered as cross-platform, and Arduino IDE works on Windows, Mac OS, Linux, and other operating systems. So this programming environment is very simple for newcomers, and it is very flexible for advanced users. So as I told you before, so Arduino is an open source electronic platform. So it considers both hardware and software, which allows users to modify and extend them as it is needed. So we'll see some more things about Arduino hardware. So when you consider Arduino hardware, it offers a wide variety of boards tailored for different needs. So to begin using with Arduino, so to begin using with Arduino, you have to install the Arduino IDE on your computer. And next step is you have to connect your Arduino board via USB. So next step is to write or load a program. So for example, you can say you can add a simple program to control an LED, and after writing the program you can upload the program to the board and you can observe the results. So including all the experiments and the new projects, you can make use of this Arduino. So where you can explore boards like MKR series for IoT applications and Nano series for compact designs. So next we'll move on to understanding the hardware. So this is the hardware. So in the next slides we'll be learning about the components used in the hardware. So this is the basic understanding of the hardware. We'll see the components one by one now. So first it is USB. So here the USB can be used for both power supply and communication with the IDE. And next we have barrel jack, which is used for power supply. And next we have voltage regulator, so which regulates and it stabilizes the input and output voltages. So we have components like crystal oscillator, reset pin, 3.3V pin. So it is used for output. 5V pin, which is used for 5V output. Ground pin, it is used to ground the circuit. Win pin can be used to supply power to the board. And we also have some analog pins from A0 to A5. So these analog pins can be used to read analog signals to the board. So these are the components of Arduino, and next we'll see the components of Arduino, where it acts as the brain of the board and it executes the code, which is uploaded via the Arduino IDE, and it controls the input and output operations. So here there are some extra components for Arduino which is mentioned here. So we have a microcontroller, so which is considered as AT Mega 328. The processing and logical unit of the board is nothing but the microcontroller. And here we have ICSP pin, and it is a programming header on the board, and it is also called as SPI. And we also have a power indicator LED, which indicates the power status of the board. And we have RX and TX LEDs, so where it can be represented for receiver and for transmitter. So receiver is represented as RX and transmitter is represented as TX. So blink is used while sending or receiving serial data respectively. So we also have digital input output pins. So 14 pins are capable of reading and outputting digital signals. So 6 of these pins are also capable of PWM. So other than all these pins and components, we have REEF pins, which can be used to set an external reference voltage as the upper limit for the analog pins, and we also have reset buttons which can be used to reset the board. So next we'll be seeing about the Arduino Wi-Fi connection to Raspberry Pi. So here you will be considering ESP8266 as a Wi-Fi module. So it ensures both devices are on the same network or frequency channel. So here we use proper power supplies for modules like ESP8266 or NF24L01. So we have some setups. So debug using serial monitors can be done to verify data transmission. So we have some advanced features and customization of Arduino IDE. So where we have external tools and plugins with the Arduino IDE. So it is designed which is very flexible and it is extendable, allowing the users to incorporate external tools, and we can also use plugins that can significantly enhance the development process. So by integrating all these tools, you can also add new features, streamline your workflow, and you can also improve your coding experience. So setup ESP 8266 on Arduino can be done. So you have to connect ESP8266 module to the Arduino, and next step you have to install the ESP8266 library in the Arduino IDE, and you have to write and upload the code. So sample code is given here. So after writing the code, you can configure the Raspberry Pi. So use Raspberry Pi on the Raspberry Pi to send, use Python on the Raspberry Pi. So we can send HTTP request to Arduino's ESP8266 server. And next you have to install the request library. So in that case, you have to use pip install request, so the request will be granted, and after this step you have to go for test communication. So you have to ensure both devices are on the same Wi-Fi network. So here you will be using external debuggers. Debugging is nothing but it's an essential part of software development. So but the standard Arduino IDE lacks built-in debugging tools. So here you can consider integrating the external debuggers such as Visual Studio Code with platform input output, or you can use hardware debuggers like JLink, etc. So moving on to some platform input output integration, you have to know what the system is. So you have to understand platform IO is an open source ecosystem. So that works with various embedded platforms. So here you can consider the example as Arduino. So it provides debugging capabilities, so you can navigate the code, and also you can consider powerful build systems. So you can use it within Visual Studio Code. So you can offer a sophisticated coding environment, and you can compare the default Arduino IDE, setting up the platform input output with Arduino. So this thing is, first you have to install the Visual Studio Code for the official website. Then you have to open up Visual Studio Code, and you have to go to extensions. So you will be having a four square icon on the sidebar. So you have to choose that, and you have to search for platform input output IDE, and you have to click install. So once it is installed, you have to go for platform input output setup to develop environment. So that supports Arduino and other microcontroller platforms, where you can use it for debugging, code completion, and error checking features. So adding board definitions manually can also be done. So this Arduino IDE boards manager covers most commonly used boards. So there you can use different timings when you can need to custom board definition manually. So manual installation on board is also possible. So here you have to find out the URL for the board's JSON file provided by the board manufacturer or community. So the procedure is, you have to go to the file, select preferences in the Arduino IDE, and under additional board manager URLs, you have to paste the URL of the board definition, and you can add multiple URLs separated by commas. So you have to restart the Arduino IDE, go to tools, select boards manager, and search for newly added board definition. So the next step will be make file integration. For those who prefer command line tools, or you have to need to automate the build process, you can use Arduino that can be used with making files. So this allows you to compile, and you can upload the sketches from the terminal. So along with that, you can integrate the Arduino projects into larger software builds, or you can use version control systems like Git more effectively. So setting up a makeup file for Arduino is possible here. So we have some steps to be followed. So you have to create a makeup file in your Arduino sketch folder. So next step is to define a variable such that you can specify the board type, port number, Arduino directory paths, and so on. And moving on to the next step, you can use terminal commands like make terminal commands to make compile and upload the sketch to your board. So next step will be customizing IDE appearance with themes. So here visual appearance can be customized. So you can also modify the themes here. So you can change the color scheme, or you can change the font size, syntax, highlighting, and so on. So by making use of code, you can change, you can apply changes, and it should be visually appealing. Okay, so changing the theme is also very simple. So you have to navigate the Arduino IDE installation directory. So the process is, first is you have to go to installation folder, library, and then theme. So you have to back up the existing theme files before making any changes. And next step is to replace the existing theme files with your customized theme files or download a theme from online Arduino forums and communities. Next step is to restart the Arduino IDE to apply the new theme. So these are all the procedures to be followed. And next step is you have to learn about the Arduino development environment. So in Arduino development environment, we have some tools and software to write, compile, and upload code to Arduino boards. So here you have to learn about the configuring serial communication in the Arduino boards. So serial communication is a crucial aspect of Arduino, which develops allowing you to exchange data between your Arduino board and your computer. So the serial monitor and serial plotter tools in Arduino provides a way to visualize and you can debug data in real time. So serial monitor is used. So it is a built-in tool. So it allows you to send and receive text-based data to and from Arduino. So it is commonly used for debugging, testing, and it is used for interacting with the Arduino using during development phase. So next step is the open the serial monitor. So here we have to proceed with these two steps. So click the magnifying glass icon in the top right corner of the Arduino IDE. So you have to go to Tools, Serial Monitor, and a new window will open. So displaying the data from your Arduino. So you can also set up the baud rate. So ensure that the baud rate is in the serial monitor. So it should match the baud rate in the baud rate in your sketch. So so you have to mention the baud rate. So it determines how fast the data is transmitted, and you have to see whether the Arduino and the serial monitor for proper communication. So you can also send and receive data. So this can be done by using the text input box at the top of the serial monitor, and you can send commands or data from your Arduino. So you can also use serial.print method and serial.println functions in your sketch to send data from the Arduino to the serial monitor. So this is all about Arduino development environment. So again, you will be seeing about Arduino IDE. So already some basic points were given for Arduino IDE. So it is primarily a development tool. So it is available in two versions here. So one is Arduino IDE 2.x. The second version is Legacy 1 IDE 1.8.x. So Arduino is a command line interface. So we call it a CLI. So which is used for advanced users. So it usually allows you to compile, upload, and it can also manage libraries, and you can also board directly from the terminal. So this process is very ideal for automation. It can also be used for scripting, integrating Arduino workflows into other tools. So when you consider Arduino Cloud Editor, so it is an online IDE accessible via a browser. So it enables coding, uploading, and making projects. You can also manage projects from anywhere. So it is particularly useful for Chromebook users, for those who prefer not to install software locally. So moving on to the versions, Arduino IDE 2.x is the latest version. So it supports features like auto completion, code navigation, and live debugger. So it supports Windows, Mac OS, and Linux. So installation involves downloading the appropriate installer or app image for your operating system, and setting up instructions has to be followed. So library manager simplifies adding libraries to your projects. So next we'll move on to Legacy IDE 1.8.x. So it's a older version which is still available for users. So with a simple interface, we are using this version. So it supports all Arduino boards and it is compatible with older systems. So next we'll see what about the installation and setup of Arduino IDE. So first you have to install Arduino IDE in Windows. You can install in Windows, Mac OS, Linux, Chromebook and so on. So the first thing is you have to, when you install Arduino in an Windows, you should download the .exe or .msi file. So you have to run the file and you have to follow the setup wizard. So we'll follow the steps here. So first you have to run the installer. So to run the installer, you have to double click the downloaded .exe file. So you can launch the installer. So you may be prompted by Windows user account control. So where you can confirm that you want to run the installer, and then you have to click yes. So you have to accept the license agreement. So go through the agreement and then you can click I agree to proceed. So you can select the components by default. So the installer will select all necessary components including the core IDE, USB drivers and shortcuts. So it recommends to leave all options, especially the USB driver installation, which allows your computer to communicate with Arduino boards. So next we will be seeing about choosing the installation folder. So you can install the IDE in the default directory. So usually you will be having it in C program files Arduino, or you can select a different location. So next you can install the IDE. So you have to click on install to begin the installation process. So the installer will copy all necessary files, and it will configure the IDE on your computer. So once the process is completed, you can click close to exit the installer. So these are the procedures for installation and setup. So next we'll be learning about the additional tools. So here you will be learning about MicroPython support, and next we have Arduino PLC IDE. So here in MicroPython support, Arduino boards can also be programmed using MicroPython with dedicated resources available for setup. And here in Arduino PLC IDE, it is mainly used for industrial applications. Uh, So it supports Arduino sketches. And here we have some steps to install the libraries. So here you have to open the library manager. So go to sketch. Next you have to include library, manage libraries. So when you proceed with these steps, you will see this will open the library manager window where you can browse, install and update all the libraries. So search for the library is also possible. So using the search bar to find the library you need can be done. So for example, if you need to control a servo motor, you can search for servo to find out the servo library. So install the library can be done. So you have to click on the desired library from the search results, and next you have to click the install button. So the library will be downloaded and it will be installed automatically. So next we'll be seeing about Raspberry Pi. So Raspberry Pi, so you have seen some basic introduction about Arduino, and here we are going to learn about Raspberry Pi. So it's the size of a credit card computer board, which is developed by Raspberry Pi Foundation, and it was developed in UK. So Raspberry Pi is a series of powerful small single board computers. So here the device has a single core processor, and it ranges from 700 megahertz to 1.2 gigahertz, and a primary memory range from 256 megabytes to 1 GB RAM. So to store the operating system and the program memory, we have SD cards where we can use SD cards. So Raspbian OS is also used, and some third-party operating systems can also be used, like for example, RISC OS Pi, Diet Pi, Kali, Linux can also be run on Raspberry Pi. So next we'll be saying about Raspberry Pi diagram. So we have Raspberry Pi here. So we have a camera module. So we have 40 pin GPIO. We have an SD card slot, and we have a dual USB slot. We have Ethernet slot also, and we have micro HDMI ports, power supply, RAM, ROM, microprocessor. Everything is given here. So, so it is considered as a versatile computer, so that can be utilized by people in all groups. So it can be used for watching videos on YouTube, watching movies, programming in languages like Python, Scratch, and many more. So, as I told you before, there are a series of input-output pins that gives this board the ability to interact with its environment. So you can use these particular interactive projects, and we also have some examples for using this Raspberry Pi. So it can, for example, we can say it can be turned into a weather station by connecting some instruments, and you can check the temperature, wind speed, humidity, etc. So it can be turned into a home surveillance system due to its small size. So by adding some cameras, we can also ensure the security network. So it can also be used in other applications as well. So this is the basic Raspberry Pi diagram. In the further slides, we'll be seeing about the other parts of Raspberry Pi. So next we'll be seeing about the Raspberry Pi model. So there have been many generations of Raspberry Pi from Pi 1 to Pi 4. So we have Model A and Model B. So Model A is very less expensive, and we have some variants here. So it reduces RAM, and dual cores such as USB and Ethernet can also be considered here. And we have some list of Raspberry Pi models. For example, like Pi 1 Model B is released in 2012. Pi 1 Model A is released in 2013. Pi 1 Model B Plus is released in 2014. Pi 1 Model A Plus was released in 2014. And next we have Pi 2 Model B, which is released in 2015. Pi 3 Model B is released in 2016 again. And Pi 3 Model B Plus is released in 2018. Pi 3 Model A Plus is released in 2019. Pi 4 Model A is released in 2019. Pi Model B is released in 2020, and finally we have Pi 400, which is released in 2021. So these are the models and variants of Raspberry Pi. So moving on to the features of speeches and specifications. Raspberry Pi is a credit card size computer, so that can be used to connect monitor or TV, and it functions as a fully operational computer. So Raspberry Pi has evolved through multiple generations. So it includes models like Pi 1, Pi 2, Pi 3, and Pi 4, and Pi 400. So each generation introduces some improved performance, memory, and features. So considering the model A, so it is a budget friendly option with the reduced RAM, and it has very limited ports. So when you consider model B offers more robust features, and it includes additional USB and Ethernet ports. So when you consider Pi 400, so it has integrated the computer into a keyboard for a plug and play experience. So considering this Raspberry Pi, the processor speed ranges from 700 megahertz to 1.8 gigahertz. So memory options are from 256 megahertz to 8 GB RAM. So storage can be done via micro SD cards. So connectivity options are given like HDMI, USB ports, Ethernet and Bluetooth. And we have general purpose input output GPIO pins for physical computing and IoT projects. And next we are going to see about the Raspberry Pi. So we have various components for Raspberry Pi. So we have USB ports, RJ45 port, so which is used for Ethernet cable to get access to the internet. And we have an audio component, so it's an output port for speakers. And next we have HDMI port. So this can be a normal HDMI output, and other variants can also depend on the model. And here Raspberry Pi 4B has two outputs, so two dual monitors can also be used here. So based on the power supply, Raspberry Pi typically is powered with USB. So the connector is also different based on the model you have worked. So basically it works with a phone charger. So next we have micro SD slot, wireless card. So wireless card mostly for models we can use for Wi-Fi and Bluetooth. And we have some processor, and next we have memory. So when you consider the memory, Raspberry Pi comes with RAM, so starting from 256 MB on the oldest model and 8 GB on the most powerful. So it varies from 256 MB to 8 GB. 8 GB considering the memory. So about 4 GB to 8 GB, you can the size is very useful, and you can work on laptop with the good interaction. So next we'll move on to Raspberry Pi, which also include connectors. So first you have to understand what is the purpose of using Raspberry Pi. So Raspberry Pi can be used for a wide range of products. For example, desktop computer, especially to learn programming for electronic circuits like robots or programming experience, or host various servers for example like file or web servers, etc. You can use Raspberry Pi. So you have to know how you should install Raspberry Pi. So as a general rule, you can consider Raspberry Pi will run on Raspberry Pi OS. So Linux based system can also be used, for example like Debian. I especially you can use it along with Linux distributions, Android, Windows and systems, where you can specify with goals for the media center and so on. So here in Raspberry Pi, you have some connectors where we have GPIO pins, the camera port, and the display port. So the camera port, you can plug a cheap camera module, and you can use it with Python or other programming languages. And considering the display port, you can connect the official monitor directly. So you can use HDMI port on every model. So this is all about the connectors in Raspberry Pi. And next we'll move on to operating systems. So the recommended operating system in Raspberry Pi is formerly called as Raspbian. So it's a Linux-based system optimized for hardware. So there are other compatible OS options, which includes Kali Linux, Diet Pi, and RISC OS. So, considering the applications and projects in Raspberry Pi, so due to its versatility, it makes it suitable for a variety of projects. So, programming is easier. So, it is useful for learning Python, Scratch, and other languages, and you can use it for IoT and automation. With the help of GPIO pins to local sensors, motors, and other devices, you can use this. So, considering the media center, we can stream videos, we can also play music, and we can set up home theater systems. So, considering the DIY projects, you can create weather stations, you can work on home security systems or retro gaming consoles. So moving on to education, you have teach coding, electronics can be done. So robotics can also be used in schools and colleges. So to begin with the Raspberry Pi, we need a power supply. So it preferably we can consider the power supply. We should have a micro SD card for the operating system. So monitoring TV display along with the HDMI cable should also be invoked. So here we need a keyboard and mouse for input and so on. So these are the basic steps, and before beginning with Raspberry Pi, you have to check with all these components. So the step one is setting up your Raspberry Pi. So to begin setting up your development environment, you have to first understand the development environment for Raspberry Pi. So which is where you can ensure you can connect your Raspberry Pi to your monitor, keyboard and mouse, and you can power it up with using a micro USB power adapter. So once your Raspberry Pi is booted up, you can proceed with the software installation. So the thing is, you have to make sure your Raspberry Pi is properly connected and it is powered properly. So you have to attach a monitor, keyboard and mouse to the board, and then you have to plug in with a micro USB power adapter to turn it on. So once the Raspberry Pi boots up, you will be ready to move on to the installation of the software process. So the step number two is nothing but installing the operating system. So here you will be installing the operating system. So when you consider the most widely used Raspberry Pi is Raspbian. Debian based Linux distribution tailored specifically for the platform is also designed. So here you can also visit the websites to download the latest version, and you can also follow instructions to install it in your device. So these are the basic setting up procedures. The step number three is considered as installing necessary software and tools. So here are some essential software and tools. So Python Raspberry Pi supports multiple programming languages. So when you consider Python, it is most commonly used language for developing software for Raspberry Pi and so on. So you can install Python on your Raspberry Pi by running commands, where you can install Python in the terminal. So next, once the operating system is installed, you will need to install the necessary software and tools to start developing software for Raspberry Pi. So we can also have a other version called as Git version. So where Git version is considered as a control system that is widely used by developers to manage their code base. So you can install Git on your Raspberry Pi by running the command sudo and you can install git in the terminal. So okay. So considering the integrated development environment, so the software application provides comprehensive facilities. So it ensures the software computer programmers for software development, and you can also use proper IDEs like Tony, Gianni, and Visual Studio Code for developing software for Raspberry Pi. So these are the basic ideas in installing the necessary software and tools. And next we'll have connecting to your Raspberry Pi remotely. And step number 5 is nothing but testing your development environment. So after setting up your development environment on the Raspberry Pi, you can streamline your workflow by connecting to it remotely from the computer. So this allows you to manage projects without needing a direct monitor or keyboard. So when you consider remote access tools, we have SSH. We call it as a secure shell, which is ideal for command line access and file management. So next we have VNC, virtual network computing. So where we have provided with a graphical interface, letting you to interact with the Raspberry Pi desktop, which can be done remotely. So we have some varying tools like SSH, we call it as secure shell, VNC, we call it as virtual network computing. So we can use all these to connect your Raspberry Pi remotely and you can work on your projects. Considering using the other method, you can develop, debug, and deploy code from the other main workstations. And we have the last step called as verifying your development setup. So after you have installed all the software and tools, it is important you have to confirm that your development environment is functioning properly. So a very quick process has to be checked. So you have to see whether the writing and executing a simple Python script on your Raspberry Pi is okay with it, and this test ensures that your setup is ready for coding, compiling, and running projects without any issues. So these are the basic steps, and here you will be learning about setting up the development environment. So here we'll be seeing some steps to be followed. So setting up a development environment for Raspberry Pi is very straightforward. So we have some following steps to be followed. So first you will need to purchase a Raspberry Pi board. So you should also have micro SD card and a power supply. So after all these purchasing of Raspberry Pi, everything is over, you can download the operating system for your choice from the official Raspberry Pi website. So the next third step is to use a tool like Etcher to flash the operating system onto the micro SD card. So you can also insert the micro SD card into the Raspberry Pi board and you can also boot it up. And next step is you have to follow on the screen instructions to complete the setup process. So final step is to install any additional tools or libraries. As per the need, you can go for the installation of additional tools and libraries. Next, we'll move on to the connecting Arduino to the internet. So connecting Arduino to the internet enables whether we can send and receive data. So it is suitable for IoT projects, and we have two methods like Ethernet and Wi-Fi. So with this, we'll be able to connect with the Ethernet. Yeah, we'll be able to connect with the connectivity approach. So when you consider Ethernet based connectivity, it is considered as method 1. So this approach involves using an Ethernet. yeah, or module to establish a wired network connection. So here we have hardware setup. So mounting the Ethernet shield on your Arduino board is possible. So for example, we can use Arduino UNO, plug an Ethernet cable into the shield, and it should be connected to your router or network switch. So with this particular setup, we can go for hardware setup, install required library, upload, and test can also be possible with these things. So next, by using Wi-Fi, we can proceed with the Wi-Fi module. So here you have to understand the benefits of configuring network options for Raspberry Pi. So this method uses Wi-Fi shield or module for wireless connectivity. So configuring network options for Raspberry Pi offers several benefits here. So remote access is possible. So here we can configure network options. Developers can remotely access Raspberry Pi for other devices on the network. So this enables seamless collaboration and project management. So next we'll move on to internet connectivity. So by connecting Raspberry Pi to an internet or network, developers can access online resources. They can also update software, and they can install packages to enhance the development capabilities. So here we can consider the secure communication. So configuring the network options with the static IP addresses and secure connections can ensure the encrypted communication and data transfer for heightened security. So, secure communication is a great challenge, and here it is rectified by using these methodologies. So, next, considering the scalability, network options allow developers to create scalable projects. So, it is used by connecting multiple Raspberry Pi device on the same network for distributed computing. So by following the steps outlined in this article, we can consider the configuring network options for Raspberry Pi. Software developers can create a robust development environments for innovative projects. Um, so IoT applications are very common nowadays. So we can use robotic projects. We have some programming exercises, Raspberry Pi. Um, where we can have a versatile platform for experimentation and learning in the field of software development. So installation of regular library should be possible. So you can use Wi-Fi library available in the Arduino IDE. The final step is upload and test. So already I have told you about this. So upload the code and monitor the connection status in the serial monitor has to be done. So next we'll configure the Arduino. So Arduino is an important device used in electronics engineering. So you can create many projects for integrating large projects. So you have to see how you will configure the Arduino, and we'll see some basic steps. So setting up an Arduino board involves preparing the hardware, installing the necessary software, and you can also upload your first program and so on. So here we have some steps to be followed. The first step is to install the Arduino IDE. So here we have some varying options. For example, say option 1 is considered as desktop IDE download, and you can install the latest version of the Arduino IDE from the Arduino software page. So where it is available for Windows, Mac OS and Linux. So in option 2 we have online IDE. Arduino Cloud Editor is possible here. So here the use of web-based IDE for coding and saving projects can be done in the cloud. So installing the Arduino Create Agent to connect to your board can also be possible here. Okay. So next, um, you have to configure the IDE. So you have to open the Arduino IDE and you have to follow the steps. First you have to go to tools menu and then you have to choose board and select your Arduino model. For example, say Arduino UNO. So next you have to go to tools, port, and then you have to select the correct COM port for your board. So the fourth step is to write or load a sketch. So Sketch is nothing but it's a program writer for Arduino, a program written for Arduino. We can start with a simple example like blinking an LED. So a sample program can also be added to execute all these steps. So the fifth step is to upload the sketch. So how do you upload the sketch? You can click the upload button in the IDE. You can have it in the right arrow icon. So the program will compile and upload to your board, and you can check for done uploading message. The next step is to test your setup. So if you are using the example, you can observe the onboard LED blinking at 1 second intervals. So here are some basic tips to be followed. So you can use serial monitor. So to use serial monitor, you can go to tools menu and then you can choose serial monitor to debug or view data from sensors. So you can also explore additional libraries like via sketch, which should include a library. Then it should include manage libraries for advanced functionality and so on. So Arduino itself consists of various components that can be programmed accordingly to the project requirements, and we'll be using some assembly languages like basic assembly languages. So in the microcontrollers, we have some controls for the execution of all the programs. So the microcontroller is equipped with components that can perform different functions. So here we have USB ports. So this port is used to establish a connection between its computer and the Arduino board. So we have USB port here, USB to serial chip. We have some digital pins, microcontrollers, analog pins, VWin, ground, 5V or 3.3V pins, and so on. And here we have USB to serial chip. So the USB to serial port is used for adding data from the computer to the microcontroller. So this is how the code is uploaded from the computer to the Arduino board. So we have some digital pins. So these pins are used for turning the LEDs on or off by using digital logic, zeros and ones. So we have analog pins. These pins are used for taking analog input. So next we have 5 volt, 3.3 volt pins. So these pins are used for supplying power to devices, and ground, this pin is used for setting a reference level. So this is about the Arduino hardware, and here we can consider the circuit where we can have an LED which is connected to pins on the Arduino board using some resistors to limit the amount of current flowing through the LED. So the reference level is set using the ground pin. So during the high or on the on state, the circuit connections will be complete. So the current will flow through the circuit components as programmed in the microcontroller. So in this state, the LED will glow, and when the circuit is turned off, the pins are set to low and the LED becomes dim due to the low current flow. So electronic signals are used here, and we have two types of signals. One is analog signal. So analog signals are the ones that can have any value in a given range of values. So this range can vary from 0 volt to 5 volt to take the libraries you can use you can use to control the software, and you can use it for software part for Arduino without the need to rewrite the already written code. So libraries are contributed for different developers, and it is needed for importing it into a module. So by including a library, you don't have to write complex code like reading a specific sensor, controlling a motor, or adding a Wi-Fi. But by simply including the free open source libraries, you can access these functions. So the line of code used for adding a library, we can say hash include library.h. So here is the setup method. So it is used to configure the program. So we can use void setup. So inside this module you can specify the programs like including the libraries and so on. And next we have a loop method. So it includes the programs that will run when the board is on an on state. So here we have a loop method. So inside this loop method you can have your main program, and you can start writing the code. And next we have delay method. So this is used to add a pause in the function for certain milliseconds as required. So if you want to specify any delay, you can specify in milliseconds. So inside the void loop, you can have a digital write method. You can specify LED whether it should be turned on or off. So turn on should be represented high, and turn off should be represented as low. So high represents turn on an LED, and low represents turning off the LED. So here you can also specify the delay with some numeric value. So delay is mentioned as 1000, so it can be represented as 1000 milliseconds. So next we'll have sensors and actuators. So it can be categorized into different forms depending on the type of quantity they measure. So for example, the temperature sensor is a device that measures temperature. So here we can add a code representing the sensor value. So sensor value is equal to sensor.read. So here it takes the value from the sensors. So the most common example of a sensor is an analog sensor that can be used for measuring a continuous range of values, generally from 0 to 5 volt. So next type of sensor, we call it as digital sensor, where we can sense inputs and then generate an output in digital bits. So certain libraries have been designed to read this digital sequence generated by the sensing for measuring purposes. So this can be done by using sensors and actuators. And next we have actuators. It performs the task of using the signal to actuate something like mechanical movement when an input is sensed, or turning a light bulb on when voltage is received. So here you can consider the actuators where it can respond to input signals by triggering an action. So, for example, such as initiating mechanical movement or switching on a light when voltage is detected, and so on. So, these are the examples you can consider for actuators. So you should know how Arduino responds to signals. So Arduino acts as a bridge between sensing and action. So it also monitors the inputs, and signals from sensor or voltage changes can be done, and then it performs um, a task based on the input. So this is the essence of embedded control, and we have some input detection. So here we can consider Arduino, where it reads the signals from the sensor or switches. So these signals can be digital, it can be mentioned as on or off, or analog, varying the voltage. So considering the signal processing, the microcontroller interprets the input using programmed logic. For example, if you want to check a button when it is pressed, or light intensity drops below a threshold, you can have some microcontroller interprets. So next we have output actuation. So based on the output, Arduino activates an output device. So mechanical movement like rotating a motor or opening a valve, visual feedback like turning an LED or display, or you can use sound or alerts like triggering a buzzer or sending a signal to another system. We also have some example coding for this. So you can also use some examples here for reading the values from the sensor and so on. So here you will be learning about the Arduino structure of Arduino. So different Arduinos are designed to serve different purposes, but some basic components are needed for every Arduino. So here, as I told you before, we have seen some components already. So I'm specifying some more components. Um, for example, we have processor where we have represented 16 megahertz, 80 mega, 16 U2, and we have a flash memory 32 KB, and RAM we are using as 2 KB. Voltage needed is considered as 5 volt. Input voltage is 7 to 12 volts. Analog input pins is considered as 6, and number of digital input output is considered as 14, with 6 of them being PWM pins. So next, first you have to consider the Arduino programs. We call all the Arduino programs as sketches. So as they follow a simple structure composed of two main functions. Initially we use setup. So it runs once when the board is powered on or reset. So it is used to initialize settings like pin models, and it is used in serial communication, etc. and so on. So you can use void setup method here, and you can also use loop method, so where it runs repeatedly after setup finishes. And it also contains the main logic that keeps executing here. And we also have a void loop where you can also have the code main code, which can also be written in this particular method. So as I told you, Arduino programs are called as sketches, and you can also perform various methods, which is used to initialize settings, pin model, serial communication, and so on. So these are the structure of the Arduino. And next, moving on to the setting up of Arduino, you have two steps here. So it can be used for installation, Arduino software packages, and you can use it for Windows setup. So first you have to plug in your board to the computer, and you will see a driver installation setup box on the screen. So installing the Arduino software packages should be done here. So to install the Arduino software, first you have to visit the official website, and you have to download the latest version that is valid for your computer. So here is a list of steps you have to follow during installing Arduino integrated development environments. So the Windows setup is specified. So you have to plug in your board to the computer, and you will see a driver installation setup box on the screen. So you have to grant access to the connecting the Arduino to the computer, and in case if it fails, you have to go to the start menu, and you have to select control panel. And the next step is to go to the system and security and select system. So after this opens up the device, you can go and set up the device manager. So if you carefully observe the ports, there will be an open port associated with the connected Arduino named Arduino UNO. So that we call it as COM XX. So you have to right click on the name Arduino UNO. So here we have COM XX. Here you have to consider in this case, and you have to select update our driver software. And the next step is to search for driver software by selecting browse by computer. So search for the UNO's driver file can be done, which can be named as Arduino UNO.inf. So which is located in the driver folder for the Arduino software download. So these are the process. So the thing is, first thing you have to install the Arduino software package. To install this Arduino software, you need to visit the official website, and you have to proceed it with the installing Arduino integrated development environment. And next you have to set up the Windows. So you have to plug in the board to the computer, and you have to perform the driver installation setup box on the screen. So you can also grant access to connect the Arduino to the computer. And in case if it fails, you can go to the start menu, and you can go to the control panel. So after this process is over, you can go to system and security. You can choose system. So after this, you can open up the device manager, and you should carefully observe the ports, and there you will be opening open port associated with the connected Arduino, and it should be named as Arduino UNO. So you should also right click on the name. So in this case you can specify COM XX, and you have to select update driver software. So after this process is over, you have to go for search for driver software by selecting browse my computer. So search for UNO's driver file will be named as Arduino UNO.inf. So which is located in the drivers folder for the Arduino software download. So this is all about setting up your Arduino. So next we'll move on to running the Arduino software. So the thing is, the Arduino is very useful, and it is budget friendly device that can be used for basic projects. So once the Arduino application has been installed on your device, you have to open the software for the associated Arduino. So then you have to follow some steps. The first step is to connect your Arduino board to your computer, and you have to use some connecting cables. So after this connection procedure is over, you can go to the software icon. So the software icon will appear at the location where you have installed the Arduino application. So you have to double click it for the you have to double click it to open the interface. So you have to follow this order. So you have to go to file menu, you have to go to examples, basics, and then you have to select B-Link. So when you open the application, the screen will show the code written for the Arduino, and now you have to now you have to get this code on the Arduino. So after the process is over, you can upload your code on the Arduino select tools, and then you have to choose board, and then choose the required Arduino model like Arduino UNO and so on. So after this step is over, you need to specify the serial port from which the board will take data. So you can go to tools, you can select serial port, and then you can select the port, uh, and you can proceed with the other steps. So Windows users can select port COM3 or similar ports, and for Mac or Linux users, they can select slash DEV slash TTY dot USB modem. So carefully look at the left portion of the screen, and you will see the upload button, and you can click on it. So now with a short period of time, you will observe receiving RX and transmitting RX LEDs on Arduino, which illuminates done uploading message on the screen. So in case if this particular does not appear, there should be some error to follow the steps. Follow the steps. In case error appears, you have to carefully do the process again, and then you will be having a suitable message indicating done uploading message on the screen. So till done uploading message on the screen appears, you have to proceed with all these procedures. So this is running the Arduino software. So we have some steps. The initial step is in the Arduino application. You have to double click it to the open interface. You have to follow file. You have to select examples, basics, and B-link. So when you open the application, the screen will show the code written for your Arduino. And now you have to get this code on the Arduino, and you have to upload code on the Arduino. You have to choose tools, and then you have to choose board, and then choose direct your Arduino model like Arduino UNO. So after this step, you need to specify the serial port which the board will take data. And the next step is to go to tools, select serial port, and then you have to select the port. So in Windows you can select port COM3, and you can proceed with the further options. When you see it in the right hand side, you will see an upload button, and you should click on it. So within a short period of time, you will observe receiving RX and transmitting RX LEDs on the Arduino, so which denotes the done uploading messages on the screen. So the ability of Arduino is to provide a programming interface, and it allows features like detection of data from the environment, and it makes it a great choice for designers and artists. Uh, and so these are the basic advantages of using Arduino software. So we have seen the procedure for running the Arduino software. So next we'll see configuring your Raspberry Pi board. So the initial step is to install your Raspberry Pi. So we have some set of procedures to be followed to install Raspberry Pi. So first step is to download the Raspberry Pi imager from the official page. Second step is to use the Raspberry Pi operating system. The third step is to select the SD card, and you have to click write. And next step, you have to add the Raspberry Pi to the monitor. And moving on to the next step, you can skip the update for the time being. And next you can click restart to complete the process. So using of Raspberry Pi can also be denoted. To use Raspberry Pi as a beginner, you have to go to Raspberry Pi menu bar. So use browser, file explorer, and terminal to explore the things, and you can also use Raspberry Pi menu to execute more tasks. So here when you consider installing Raspberry Pi, we have section 1. So it configures Raspberry Pi OS for installation. So before we begin installing anything on your Raspberry Pi, we have to make sure the operating system is set up properly. So after the operating system is set up properly, we should follow some step-by-step procedure. So we have some steps to be followed. So step number 1 is you have to browse the official page of Raspberry Pi to install the Raspberry Pi imager. And next step is to click on the download buttons. And step 2 determines selecting the Raspberry Pi operating systems. Step 3 involves selecting the SD card, and you can click write to start the process. In section 2, we'll be seeing about first time Raspberry Pi booting for installation. So in this section, you will say, go through the initial steps of booting, booting your Raspberry Pi for the first time. So this is where the adventure you can see here. So it begins with numerous steps. The first step, you have to add the SD card to the Raspberry Pi board, and you can boot for the first time. So click on the skip to bypass the update for the time being. So you can use the update, and you can go to the background for rebooting process. So the next process is step 2. Under section 2, you have step 2, where you can click on the reset to complete the installation process. So in wrapping up, using Raspberry Pi, yeah, it offers a whole new world for beginners, um, which provides basics for setting up a Raspberry Pi, to explore what we can implement in Raspberry Pi with small creativity. So a Raspberry Pi is not a computer, it's a key to learn, and you have some creativity options where you can make all kinds of cool things like home automation system and so on. So these are the procedures to be followed configuring your Raspberry Pi board. So you should install Raspberry Pi, and you have to use Raspberry Pi to enhance the Raspberry Pi operating system. So we have some procedures to be followed. So all the procedures are given now. So we have 7 steps to be followed. So these are the 7 steps to install the Raspberry Pi.